So what we're going to do today, so everybody has their notes out, I'm assuming, right? It's really important that you write this down. And I'm about to actually talk about these things. Somebody just asked, so types of real numbers, are there such things as unreal numbers?
Yes.
Yes, there are. They're actually called, this is crazy, they're called imaginary numbers.
No.
And it's an actual real part of math. And we're not going to go into much this year, but when you go into Algebra 2, you're going to learn all about imaginary numbers. And I can give you examples, but maybe at the end of the lecture if I still have time, because I just want to be sure I have plenty of time. But on your paper, you know, I want you to basically figure you're going to use half, the top half, to draw a diagram. Okay? And in the very beginning, all right, right in the middle, you're going to have a little circle like this. And that little circle is called counting numbers, and I'm going to do that as an abbreviation, is that okay? For numbers, and then natural numbers. Okay. Now,
Wait, this is in the same circle?
this is in the same circle. They are exactly the same thing. Counting numbers and natural numbers. You know how in English sometimes we have two words that mean the same thing? Well, that's what we have here in math. Don't ask me why, but we do. But when I think about it, what's the root word what's the root word in natural? What? Nat. Well, yeah, go a little longer. Nature. Nature, right? Natural, nature, right? If I got rid of the AL and put an E in there, it'd be nature.
And also
Right? In nature, what do you get? Like if you want to count pomegranates or coconuts, you go up to the coconut tree. What do? You start with 1, 2, 3. Oh, that's so easy. So it's the same thing. In nature, when you see things, you start with 1. Am I right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It keeps going forever and ever, right? So natural numbers, they start with 1, 2, 3, 4, and they always go positive. They're always positive.
This all has to be in that.
Do they have a 0?
No.
No!
Maybe.
When you were a caveman and you were walking around and suddenly you came to this, I don't know, do they have caves in where there's palm trees or coconut trees or something?
Yeah.
Come to a coconut tree. You wouldn't start saying, oh,
0.
look at the 0 coconuts. Right? You don't do that. 1, 2, 3. Right? You know, you count, you start with 1, right?
So is 0 like an imaginary number? Or is it a count?
Oh, that's a good question. Is 0 an imaginary number?
No. 0 is 0.
0 is 0.
I
0
think
is
0
not imaginary.
0 isn't positive or negative. 0 is just like this whole other category.
0 is the
Well,
attitude,
0
the
is
bridge
just for
between
everything
worlds.
Yeah, it's more
So the funny thing is though, guys, the cool thing is it was a long time throughout history that we did not have such a thing as a 0. And it wasn't, and I don't even know the dates, I'd have to look it up and find out. But it was a certain you know, civilization suddenly realized, well wait, if I have 10 kangaroos, right? Or 10 camels in my backyard, right? And then somebody comes and takes my 10 camels away, and I go out to count my 10 camels. How many do I have?
You just don't
I don't have any, right?
lines
And
make
so
sense.
at one point they realized, oh my God, we have to have a number that
Nothing.
indicates nothing. And so that's when 0 was born, and that,
number is called.
my friend, is called a whole number. Whole number.
Oh, yeah, that just has a hole in the middle. Ha ha. Wonderful.
That's
Yeah,
interesting.
still
Never
does.
thought of that before. That's very cool. All right. Whole numbers are the same thing as counting numbers or natural numbers, except they added one number. What do you think that one number was?
Number 1.
0. So it starts at 0, and it goes 1, 2, 3, 4. You notice that they're all, whoops, 6. You notice that they're all whole, they're all, like there's no fractions, right? See that? Okay.
Isn't,
So now the cool thing is all the natural and counting numbers are also whole numbers, right? 1, 2, 3, and 4 are also part of the whole numbers. Do you see that? But the 0 is not part of the counting numbers, natural numbers. Now,
are there fractions or decimals, or is it just counting?
in what? they're not
Fractions
they're not they're whole numbers but not starting with zero,
Okay.
basically, right?
So it's.
But you could write them as a fraction, right?
Right,
But they're
but you could, but 4.5, four and
no,
a half
no,
isn't.
no.
So
Because
say
you didn't.
there's
The
4 and a
caveman
half,
didn't
so
go.
that's-
The caveman didn't go. 1 3/4, 2 7/8, 5 and they don't do that. They didn't do that,
But
right?
it wasn't like, oh, I see one coconut and then like
Yeah.
half the coconut. Coconut split in half.
Yeah. So so now we have above that. Let's see. What do we have? Integers. Integers. And integers are things like this. They're whole numbers, but not only do they include the 0 and the 1, 2, 3, 4,
Fractions and negatives.
not fractions, but negatives. Because they suddenly, at one point in time, we finally realized, oh my God,
We go backwards.
when I give Dylan $100,000, I am negative $100,000, right? Don't have any anymore, right? Well, actually, no. Sorry. That would be 0. I'd have 0.
Then you would just
But
have 0.
if I borrowed $100,000 from Dylan, then it means that I don't have $100,000. I actually owe $100,000. I've got to earn $100,000 to pay him back, so that I'm back to 0. Does that make sense? So debt is an example of a negative number, right? It's used in money a lot. So it would be like -3, -2, -1, 0, 1, 2, 3, 4, and they go on and on in each direction, right? These keep going on and on. All right. So far that's that. Then there's another category called rational numbers. Rational numbers. Rational numbers. What is the root of rational?
Ratio.
Ratio. What's a ratio?
Fraction.
A fraction.
So it's not numbers.
Oh, there's the fractions that we've been looking for. So yeah, rational numbers are ratios, they're fractions. So 1/2, 3/7, 9/10. Negative, can they be negative? Yes, they can be negative. -2/3, they can be anything, as long as they're a fraction.
It means, but like things like pictures, like not crazy, like rational, like they're rational numbers, not out of the way crazy, like.
Well, they could be,
Like
they could be,
1.36721984 over 5.659.
yeah, but if you did that, 1.3695 over 6.8213, if you use a calculator, right, you would get a decimal, and then you could convert that decimal to a fraction. So you could write that as a normal fraction. Do you see what I'm saying?
Yeah.
Right? So I'm really more talking about just writing them as fractions here. But notice, this is interesting. Every bigger circle includes the littler circles, right? So whole numbers is counting numbers plus 0. Integers is whole numbers and counting numbers plus 0 plus the negatives, right? Rational numbers
It's out of
are all things that can be written as fractions. Can I write whole numbers as fractions? Yes. 1 over 1, 2 over 1, 3 over 1, 4 over 1, 5 over 1, right? 0 over 1. I can write anything as a fraction. So all of these are in the rational group, right? Make sense? I'm realizing I'm running out of time. It's driving me crazy. But okay, the next thing is, gotta leave myself a little space there. These are called real. Wait, hang on. Yeah. So we're going to call this real. These are all considered the real numbers. Okay. So all of these things are called real numbers. Now, there's one other category in real numbers that we don't have here, and they don't encompass all the others. They're totally separate. So I have to have a separate little circle right here. okay? And this is called, these are called irrational numbers. I think there's 2 R's in that.
Yeah, they're hard.
Irrational numbers. Now, what does rational mean again? Ratio. So these means things that can be written as fractions. What would irrational mean?
Things that cannot be.
Things that cannot be written as fractions.
But what would that be?
And so, cannot be written as fractions. Let's just write the definition first. Cannot be written as fractions. As fractions. And then also, let's see, if they have decimals, it would be non-repeating and never ending. So like pi is a perfect example. Exactly. So examples would be pi, right? Pi is 3.1415 blah 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 blah, and it goes on forever, never, 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 never. I just saw a something on YouTube about this guy who has Asperger's, autism, and he recited pi to the 22,500th character after the decimal point. Isn't that amazing? Amazing. So it keeps going forever and ever, and they don't repeat. It's not like if it would be like, you know, any number that does not have a set repeating pattern. Like if I had 4.123, that's a repeating. That would not be irrational. If I had 4.6666666, that's repeating. That's not irrational. But 4.612398743x, I mean not x, but you know, just no repeating at all in any particular order, that would be irrational. Other examples of irrational might be the square root of 2, the square root of 3. A lot of the square roots are the examples. Square root of 11, the square root of 5, the square root of 31. All those. Because if you take your calculator and try it out, you're going to get a number that never ends and never repeats, right? Yes.
There's this really cool book called Navigating Early.
Mhm.
It's like about this kid. He like knows like pi like completely, and then he like makes this whole story around it, and it's really cool.
Cool. Awesome. Yeah, pi is amazing.
Life of pi.
Some people have dedicated their entire life to studying pi. And you guys know what pi is, right?
Yeah.
Do you know what it is? Do you know where it came from? Do you know what it is? So, well, actually, before I get into pi, let me just finish this lecture part, right? And then I'll talk about pi, because I'm not going to be able to do the second part
And
of the
pi
lecture.
actually may have an end. It's not proven or not.
Oh, get out of here! You're right. It might
We just
have.
have to keep solving pi until we figure it out.
Right. Right. That would be a great test. I should give you guys a test someday. Figure out pi to the 4 billionth decimal point. Okay. Now, you guys, the cool thing is, we have this huge thing here, and these are only real numbers. There's actually a whole nother circle that would encompass all of this, plus a whole thing called unreal numbers, which are actually
Imaginary.
called imaginary numbers. And I don't know if I spelled that right. I don't know if there's 2 M's or not. I think there's one.
There's just one. No, there's just
Imagine. I think it's just one. I think it's just one. And imaginary numbers. Do you want to see an example of an imaginary number that does not exist? All right. Here we go. The square root of -4. Is that on here? Can you see that? Sort of. Okay. Square root of -4. What's this? How many people know what square roots are? Does everybody or not? Not everybody. Because I'm not expecting everybody
I
to.
don't know. I know what it is.
Square root, like a square root.
It's like what number times itself
Yeah.
equals this.
So like the square root of 4 just of a positive number, it's what number times itself equals 4.
2.
So 2 times 2 would be 4. So the square root of 4 is 2. So the square root of 9, what number times itself equals 9 is 3. The square root of 16 is 4, right? 4 times 4 is 16. And the square root of 36,
Is 4. 6.
6 times 6 is 36, 6, right? Those are square roots. But look at this. The square root of a negative number. So some people might say,
Well, some people might say that you could do a negative 2 times a negative 2, but that doesn't work. 'Cause it's a
right,
positive.
negative times negative is a
But then if you
positive.
do negative 2 times 2, that would be a negative, but negative 2 and positive 2 are different numbers.
Right, so therefore you can't do it. There's no way to do that. However, in math, as you move into Algebra 2, you will find situations where it's useful to actually assume that there is a way for this to work. And you can actually solve problems by assuming there's a well, basically an imaginary number has a special thing like this. The square root of square root of negative 4 is, well, like this is the square root of negative 1 is I.
Why?
That's what they decided that's how that's the definition of I is an imaginary number, so it's like square root of negative 1. So the square root of negative 4 is the same as saying the square root of 4 times negative 1. You agree with me? Isn't that the same thing,
Yeah.
right? 4 times negative 1 is the same as negative 4. So if I know that the square root of 4 is 2, so this would equal, the square root of 4 is 2. The square root of negative 1 is I. So you would actually call it 2I. So in Algebra 2, you'll actually be dealing with I's, 2I's, right? But right now, you have 2 I's on your head, and we'll just stick with those, okay? We're not going to deal with more I's, okay? But, all right. Did that. Pi. Well, okay. I guess that's it for the lecture. Now, I'm not able to do the whole other part of the lecture I wanted to do today because we ran out of time. So the homework I was going to give you is completely worthless. So I will create another small homework assignment just for you to practice some of the stuff we've done over the last few weeks. Does that work for you guys? Just to practice. And
Is that our homework assignment?
so I will give you a worksheet, yeah. But I have to go remake it because I thought I was going to get further.
So will you give it to us?
But tomorrow we're going to do something really cool, so be prepared.
Will
It's
you give
really
it to us
fun.
later in the day?
Really fun. I will give it to you later in the day because I have to go make it.
Throw away your whole lesson plan because
I know. All right, so that's it. We're done.
Okay, yay.
You're welcome.